All right. Well, we've got a really big agenda today, so we'll start right off the bat right now. I'm here joined with Umair from Stormatics and one of my colleagues, Alex. We're here to talk today about Postgres 101 for Oracle DBAs. Postgres is a really hot topic for Oracle DBAs and in the in the Oracle world. So let's get into it. One piece of housekeeping before we start. We have question and answers in this little button down the bottom. So if you have any Q&A, please put it in there. We'll try and respond to it during the presentation. And also for those of you who are not English as your first language, you can select show captions and then use the translation service as well. And you'll see translated captions in your language. So that might help. All right. And so a little bit of background about dbvisit and Stormatics first before Umair kicks off into the real presentation. dbvisit is a database disaster recovery company. We've been doing this for 20 years. We really work to make disaster recovery simple and easy, no matter what type of license you're using. So we operate in 120 countries today, and we have over 1,700 customers around the world. And what we really focus on is having happy DBAs, happy customers, and making disaster recovery a really simple business decision if you ever do need to fail over. So I'm joined with my colleague, Alex, who's the head of product management and development. We'll be talking a little bit later on around database continuity options on Postgres. But before that, the star of the show is Umair. Thank you for joining us today.
Thank you for having me.
Yeah, Umair and I met online, some really great posts and content about Postgres, and I knew the Oracle community would really value your perspective on Postgres. Obviously, a 20-year veteran of the Postgres community, a lot of history within Pecona and Second Quadrant, leading development and product management within those companies there. So really excited to hear about your commentary on Postgres today for Oracle DBAs. So without any further ado, I'll hand over to you and look forward to hearing.
Thank you very much. And let me see if I can quickly figure out how to share my screen. Let me know when you see it.
Yeah, we've got that.
All right, excellent. Well, thank you, Tim, for the kind intro. And we are here to talk about Postgres, give a brief intro, some history, with the idea being that if you're coming in from an Oracle background or a different proprietary database background, and you want to explore Postgres, we want to make sure that you understand what you're getting into, what to expect, what are the kind of differences, and most importantly, tackle why you should consider Postgres as a good option. So Postgres 101 for Oracle DBAs. You already saw a sneak preview of this slide from one of Tim's slides, but I am joining you today all the way from Islamabad, Pakistan. I've been in the Postgres space, in the Postgres community since 2003, so it's more than 20 years. And over the course of these 20 years, I've been part of pure play Postgres organizations like EDB, OpenSCG, Second Quadrant, and Percona. Currently, I run a professional services organization by the name of Stormatics, and our focus is to help businesses scale Postgres for critical data. Now, on to the topic of conversation. What is Postgres? It's an object relational database. It's purely open source with a very liberal license that is recognized by the Open Source Initiative, the OSI. It is perhaps one of the most liberal licenses that are out there, even within the open source community. It is compliant with the SQL standard. It's compliant with the atomicity, consistency, isolation, and durability standards that is expected of any database that's worth its name. It supports both structured and unstructured data. This is something that's pretty unique to Postgres, that is very highly extensible. The design is such that plugins can be created and extensions can be created to extend the functionality if there's a need to do so. We'll talk about that in a little bit. A little bit of a history about Postgres. It started off in 1986 in the University of California, Berkeley. And the name given at that time was Berkeley Postgres Project. Professor Michael Stonebreaker led the project at that time, and it was sponsored by a bunch of organizations that were mostly defense-related, the U.S. defense-related. Interestingly enough, it's around the same time that Cybrid, started off in the same university, and there was a lot of overlap in personnel and the research that was going on. And this Microsoft SQL Server database actually takes its roots from Sybase, and why you will see a lot of commonalities between Postgres and Sybase and SQL Server. They appear to start off with the same or a similar set of people in the same university around the same time. Fast forwarding to 1994 is when Postgres was open sourced. The code was made available to public with a bunch of improvements. At that time, it was named Postgres 95. In 1996, folks realized that it's not a name that is scalable because the year 95 is going to change to 96 and onwards. And that's when it was named PostgreSQL, or Postgres for short. And that's how it exists to this date. It's important to understand the history because it's been around for a while, and over the course of the last 30 odd years, the stability and the feature set has amassed, and it's become increasingly more reliable for production workloads. A few numbers. This is a snapshot that I actually took from the Postgres community website. It's been in development for more than 35 years. There's hundreds of contributors around the world, thousands of commits that take place every year, local user groups, and lots and lots of code. I've been part of this community for more than 20 years. It's a very open and a very welcoming and a very helpful community. Got local chapters pretty much all over across the globe. And in case you want to meet people in person, just look up the local user group in your neighborhood. I want to spend a little bit of time on this slide here and try and explain what I've tried to do with this graph. So essentially, DB Engines is the go-to authority for the various different databases that are out there. It tracks popularity, it tracks job listings, keyword searches, etc. Year over year of the database engines that are out there. And there is an annual award that goes out from DB Engines for the database of the year. Postgres has been the only database that has won that 4 times. I think the only other database that has even come close is twice winning that award, but everybody else, maybe there might have been one odd instance here and there. Postgres has been the database of the year 4 times now. Also, Stack Overflow is perhaps the most popular forum amongst developers. The go-to platform whenever developers get stuck in with any issue. And in case you do run into an issue and you Google for it, chances are that it's going to be a Stack Overflow link that is going to come up at the very top of the search results. So it has a humongous following, a very big developer community, and Stack Overflow also conducts an annual survey amongst its communities to determine what technologies are being used the most, what technologies are desired, what technologies are popular, et cetera, et cetera. And of course, databases is one of the technologies that Stack Overflow asks about. What I did over here was I took the top 5 databases as declared by DB engines, and I traced their popularity in Stack Overflow surveys over the past 5 years. And because what we're talking about is Postgres and Oracle, amongst application developers, Oracle didn't really have a very good standing or a very popular standing even back in 2020, but it has declined since then. Whereas in all of the 5 databases that you see over here, there's only one database that has consistently increased in popularity over the course of these 5 years, and that's Postgres. And if you see at in 2023, that was the first time that it overtook all other databases in popularity, and it is in 2024, the latest survey that has come out, it's increasing its lead over other databases. There is a little bit of recovery in Oracle that you see in 2024, but Postgres, by far, is the most popular database. The important thing to note over here is that this is amongst application developers, the audience of Stack Overflow. Now, what this also means is that in greenfield applications, in newer applications that are being developed, chances of finding Postgres as the backend database are very, very high because of its popularity. Now, this is not isolated. It's not just about Postgres. Open source in general is increasing in enterprise usage. Based on surveys, what we're looking at over the course of 5 years, starting 2022, is about a 16% compound growth for the use of open source software. And I just found this quote very, very interesting. This was part of Red Hat's State of Enterprise Open Source report that they published a couple of years ago, and said, the question is no longer about whether you should be using open source. It's how you should be using them and when you'll start using them. So, the question of whether does not exist anymore. That's how rapidly the popularity has been increasing. Also, a few numbers from the same surveys. IT leaders believe that open source is more secure than proprietary software. IT leaders expect to increase their use of open source software in their respective organizations. And increasingly, IT leaders have a better perception of open source software compared to proprietary software. And this is also something that I find very, very interesting. When I started working with open source and with the Postgres community back in 2003, the only reason why somebody would actually use open source or use Postgres was to save on costs. But this survey indicates that cost doesn't come in the top 4 reasons for using open source. And the top reason is better security. And then, followed by quality of the software. This is a fairly drastic change that we have seen over the course of the past 2 decades. Open source software has become a force to reckon with better quality of software and better security and better reliability in every way. Now, even though it's not just about cost, differences are pretty significant. Now, I've taken list prices off of Oracle's own website, and taken some typical functionality that needs to be used in any serious production deployment. So you don't just need the database engine, you do need to create a cluster for high availability. You will need partitioning for better scalability. You will need security to not just keep your data secure, but also comply with regulations. And if you're running in production, you will need regular updates and support for your software. And besides updates and support, everything else just comes bundled with Postgres for free with that liberal license. And pretty much everything costs you pretty significantly when you're running Oracle. Clustering is not even available. You cannot create a high availability cluster in the standard edition. You have to go to the enterprise edition, and any serious deployment needs that kind of clustering. And for a single socket, the cost can add up to $107,000 for a single year, whereas the same function, the same setup you can get with Postgres for just $5,000. So the cost differentials are humongous. The natural question that then pops up when somebody talks about cost differential is, well, you get what you pay for, so there's got to be a catch in there somewhere, which is why I want to talk a little bit about Postgres features that you can rely on for production usage. Now, on the left side of the screen, you see features related to reliability, scalability, performance, and security. That's pretty much a given. That's what you expect from a database. If a database is not reliable, you don't want to use it. If the database does not perform well, you don't want to use it. If your data cannot be kept secured, you don't want to use it. So this is kind of like a given. You expect that from a database, and you get all of that with Postgres. But I want to focus on the right column over here, which are features that are very unique to Postgres, which Postgres brings to the table that other databases may not. Extensibility, we spoke about that just a little while back, and I talked about how Postgres is designed to allow hooks and APIs such that you can create extensions for additional functionality. And in this day and age, and over the course of the past 20 odd years or 35 odd years of Postgres development, the extension ecosystem has really bloomed, and you get lots and lots of functionality with Postgres extensions. And you get foreign data wrappers, which essentially allow you to talk to other databases from within Postgres. So there's an Oracle foreign data wrapper as an example that you can get with Postgres that allows you to query data from within Oracle while using Postgres. So very powerful that way. And that also allows for the support of lots of procedural languages and lots of programming languages. You can write code in your favorite language, whether that's Java or Python or some of the more modern languages like Rust and R. You can write code in those languages, and you can run that code inside of Postgres as procedural logic. That's how powerful this feature can be, the extensibility of Postgres. There's a thriving community, a global community of Postgres enthusiasts that are there to help in many different shapes and forms, mailing lists and forums and social media. There's extensive documentation available and tutorials that are absolutely free of charge. There's a diverse contributor base, which is why I also talked about local user groups and encouraging you to find your friendly neighborhood user group that you can join and be a part of. In terms of support, you can get a variety of vendors that will provide you 24/7 support without any lock-in. So the software remains the same, and in case you are not 100% satisfied with the services of a particular vendor, you can just move to a different vendor without disrupting any of your operations, any of your software. The licensing cost is absolutely zero, no matter what vendor you go to. It's just the support services that are going to cost you. And there's strong compliance with the SQL standard and with the ACID standard within the database. And not just the compliance, the Postgres community is actually thought leaders in developing the SQL standard. And with every new iteration that comes in for the SQL standard, you will see active involvement of the Postgres community. So that also, again, is something that's very powerful. We're driving the SQL standard forward in the world. And what that has allowed to do, these extensions, the liberal license, allowing everybody to do what they want to do with the database, it has created a humongous ecosystem of tools and functionality that are available with Postgres. So it's no longer just a relational database that you can store your data in. Pretty much anything that you need to get done with your database, whether that's AI vector storage, whether that's OLAP workloads, OLTP workloads, whether it's graph database, whether it's spatial data, whatever you need, you'll find some functionality, some extension, some tooling available for it, and you can get that done from within Postgres. That's also why there's an increasing reliance on Postgres and on open source software by brands that are pretty much household names across the world. And the brand names that you see over here, these are not companies that are pulled off the internet. These are companies that over the course of the past 20 odd years, in some shape or form that I have personally worked with, that I know personally, use Postgres for critical workloads. So I only included logos that I've interacted with and personally worked with. So Postgres is being used reliably in production by major brands across the world. Now that we have established the history and the context and the functionality that you can get from Postgres, coming from an Oracle background, it's important to highlight that there are differences between the two databases, not in terms of what you can achieve, but in terms of how you achieve it, right? So if you're coming from an Oracle background and you want to learn about Postgres, come with a state of mind that there are going to be differences in terminology, there are going to be differences in functionality. You need to understand those differences to be able to achieve what you are used to achieving in Oracle. These are just samples that I have shown. The differences may be too much for a single session, but I hope that with some of these examples that I will showcase over the next few slides, you'll understand what to expect and be on the lookout when you are moving from Oracle to Postgres, or when you are ramping up on Postgres along with Oracle. One example is the term schema. That term means different things between Oracle and Postgres. So while Oracle, whenever a user is created, a schema is assigned dedicatedly to that user, and it's a collection of database objects within that schema. In Postgres, that is what a database is. So what you call schema in Oracle, in Postgres, it's called database. And in Postgres, schema is almost like a namespace within a database. So you can create multiple schemas within a database that are accessible by that single user, and you can have a collection of database objects. Procedural language, the name of the language that's used by Oracle is PL/SQL. Very similarly named, Postgres is called in Postgres it's called PL/PG/SQL. There are some subtle differences between the two languages and between the syntax that you can and you should be using between the two languages. There's several different built-in functions that you can find both in PL/SQL and PL/PG/SQL. Again, two examples that I've shared over here. PL/SQL provides NVL as a function for string manipulation, and essentially what it does is it returns to you the not null value in a group of values that you pass into it. The similar functionality can be achieved. So NVL, by the name of NVL, there's no function that exists in Postgres, but a similar functionality can be achieved with the function by the name of coalesce. So it will return, you pass in parameters, and it will return the first not null value from that set of parameters. And similar is the case with decode and case. Decode is a function that's available within Oracle, and if you want to do a comparison and a selection operation in case of Postgres, you will use the case operator. Another example, and again, this is about strings, is about how empty strings are treated. So in Oracle, a null string and empty string are treated as the same thing. So, but in Postgres, null and empty strings are two different values. So these are two different things. And the implication, I've given a sample code over here. Now, if you run this statement in Oracle, you'll get an error because you need to have a from dual at the end. So forgive me, this is Postgres syntax over here. But just to give you an idea, that if you are using case statement and you compare an empty string with a null, and you do a select case when empty is null, then yes. Oracle is going to return yes when you run the statement, but Postgres is going to return no. Oracle is going to return yes because it treats null and empty string as the same thing, whereas Postgres treats them as two distinct values, and hence it returns no. Another implication of the same treatment is when you're doing string concatenation. Now, in Oracle, if you concatenate a null string with an existing string, it gets treated as an empty string. So if you're concatenating hello with null and then with world, in Oracle, the output is going to be hello world like this. But because Postgres treats null as a distinct value from an empty string, anything that gets concatenated with a null results in a null. So string concatenation or a null string concatenation in Postgres is going to result in a null. So if you already have existing code in Oracle that you want to use in Postgres, be on the lookout for subtle differences like this between the logic in the way Oracle treats strings and the way Postgres treats strings. These are just examples. This is not a comprehensive list. There's definitely other differences between the two databases. A few other conceptual differences. The way concurrency is handled between Oracle and Postgres. Oracle uses undo segments, redo logs, and it implements a complex locking mechanism in order to ensure concurrency and consistency in data. What Postgres implements is a multi-version concurrency control. And what it does is that it creates snapshots of data for the various users that are accessing it concurrently. And depending on the isolation levels that you've set for the database, it provides locks appropriately. So the way Postgres implements the concurrency control and the locking mechanism is different from the way Oracle implements it. And understanding this control can be important in a database that is scaling and that is becoming increasingly more concurrent. In terms of security and user access, user control, and privileges, in Oracle, a user is essentially a database account that has a schema associated with it. And role is defined as a set of privileges that can be granted to a user. Now, by definition in Oracle, roles cannot own objects. Whereas in Postgres, a role can be a user or a group. And a role can own objects and have its own set of privileges in Postgres. And then privileges can be finely tuned and granted on a per object basis. At the table level, at the column level, at the row level, at the schema level, you have the authority, you have the option to assign privileges to roles in Postgres. There's also a very major difference between sysdba, which is Oracle's super user, and the super user Postgres in Postgres. sysdba not only has unrestricted access to your entire database, it can also perform system-level management tasks. But Postgres super user cannot do system-level management tasks. It does have unrestricted access to the database, but not at the system level. There are differences in management tools as well. Oracle Enterprise Manager is the most popular, perhaps, tool for managing and monitoring the Oracle database. In Postgres, you can use a combination of, and these are just examples, pgadmin, pgbackers, and pgstat statements to monitor, to manage, and to control your database. Because the ecosystem is large and it's open source, you get a variety of options and you can pick and choose what tool to use. In terms of addition, because Postgres is open source and it has a liberal license, there is the main Postgres project that is driven by the global community. The contributions come in globally. It's a thriving community, and that's the main project. That's the heart and soul of any offering that anybody gives you Postgres. The innovation cycles are fairly rapid. A new release comes out every year. In fact, we're expecting the release 17 to come out later this month. And over the past 5 to 7 years, I would say that we've averaged more than 150 new features in every major release. So the innovation cycles are really, really fast. Every new release has a bulk of new features that you can lean on and that you can utilize. Now, there are some commercial offerings that organizations put forward. They sometimes lump together various different tools and create an ecosystem around Postgres and offer that as a commercial offering. Sometimes there's a fork of Postgres that enhances functionality. But mostly the idea is to allow their customers access to the full ecosystem that includes high availability and disaster recovery, performance, and security. Examples of such commercial versions, EDB, Cybertech, and Crunchy Data, all three companies. Stormatics is a partner of all three, and they have their own respective commercial versions of Postgres or enterprise editions of Postgres that you can opt into. These are not community editions, so there is a license associated if you want a commercial version. The hyperscalers, Amazon, Microsoft, and Google, all three offer database as a service with Postgres. With Amazon, you can get RDS Postgres. With Azure, you can get Azure SQL Postgres. And with Google, you can get GCP's Cloud SQL Postgres. And then there are dedicated companies that have managed offerings for Postgres. And examples are Timescale, Ivan, Tembo, and ScaleGrid. You can go to their platforms and you can use database as a service as a managed offering from their platforms. Now, what edition you would want to choose would largely depend on what your requirements are. Some large enterprises are part of highly regulated industries that require to tick off certain checkboxes, and they require SLAs, they require 24/7 support, they require some kind of compliance, and they rely on some of these commercial offerings that I've listed up here. For the most part, however, we have seen that it's open source and community Postgres that organizations rely on, and they can use it reliably in production, and they can get 24/7 support, SLA-based support on open source Postgres. A little bit about how support works and how lifecycle management works in Postgres. You do have support options in the community channels. There are mailing lists, there are forums that the community is very active on, but you can also get SLA-based support from different vendors like Stormatics and EDB and Cybertech. And then, of course, you have the managed service offerings from the hyperscalers, AWS, Azure, and GCP. With managed services, there's a reduced operational overhead. A lot of the installation and deployment is taken care of automatically, and they make it easy to configure Postgres. So if cloud is the way to go, if the way that you want to go, you can get services from one of these three hyperscalers. As mentioned earlier, we get a major release every year, and the update process is fairly lightweight. I haven't been part of an upgrade process of Oracle, but my understanding is that upgrading major versions in Oracle can be a big project. And compared to that, upgrading Postgres, major version upgrades for Postgres is relatively straightforward. You can actually upgrade with zero downtime without any disruption in your operations. Minor releases are bug fix releases, security patches that are released every 3 months, and the schedule is announced 1 year in advance. And this link right here, postgres.org/developer/roadmap, gives you the exact dates of when to expect the next minor release. And these are in-place upgrades. There's no process really involved. You can have the database running, and the binaries are upgraded in place in a hot environment. Every major version is supported for 5 years, and the last release date or the last supported date for any release you can find at this link right here, postgres.org/support/versioning. If there is a need to migrate a database from Oracle to Postgres, there is tooling available, there are strategies available. Ora to PG is an example of a very popular tool that converts Oracle schemas to Postgres and allows migration of data from Oracle to Postgres. Amazon provides a similar conversion tool. It's more sophisticated and it's oriented towards cloud migrations. EDB as a vendor also, provides a migration toolkit that allows you to migrate data and schema from Oracle to EDB's enterprise offering of Postgres. And it typically, when you're migrating, the strategies that you need to look into are schema migrations, then data migration, any changes in the application that are required, and then subsequent testing. Now, when you're migrating schema, you need to be mindful of data types that might be different between the databases. So to convert those, because PL/SQL and PL/PG/SQL are slightly different, the procedural logic may need to be rewritten or translated, and triggers accordingly adjusted. With data migration, you've got techniques for bulk data loading and partitioning to allow for faster data loads. And for application changes, the way applications talk to the database, you want to make sure that you are making the appropriate changes. But more importantly, any application that is very tightly coupled with the database will require some changes within the application as you move from Oracle to Postgres. And once that move is done, of course, there's comprehensive testing and validation that needs to be done in order to make sure that you've done the entire migration reliably and successfully. Schematics offers a migration strategy and a migration service from Oracle to Postgres, and we have a 10-step process, starting off with an initial migration assessment and then going through schema, procedural logic, application level changes, and also setting up the clustering, disaster recovery, performance, security, and then ongoing support and managed services if required. And that brings me to the end of my deck. I understand that Tim is supposed to take over from here and present a few more things, but any questions that anybody might have, I'm happy to answer.
There's a couple of questions, Umair, so maybe we'll get a couple. One I have here is, can I use OLAP analytics in Postgres?
Yes. So the short answer to that is yes. Even though Postgres is more popular with OLTP workloads, it is possible to tune Postgres for OLAP workloads. In fact, one of the major projects that we completed successfully was to create a complete business intelligence stack for a telecom organization in which we used Postgres as a data warehouse and as a reporting database for OLAP workloads. So yes, it can be designed and tuned for OLAP workloads.
A second question we have here is, how does Postgres handle JSON data?
So you've got native support for JSON. So there's a native data type for JSON and binary formatted JSON. You've got many functions to access and store data and manipulate data. We've got JSON indexing. So a fairly comprehensive native functionality for unstructured data with JSON data types.
In the parts around roles and privileges, one question we have here is, so what are the advantages you see from going to have a role? Hold on, going to get from having a role with its own objects in Postgres.
I'm not sure I quite understand that question. Advantage of having a role with objects? Maybe you can repeat what was said. Maybe just try and listen more carefully.
From having a role that can own objects in Postgres, what are the advantages of having roles that can own objects in Postgres?
Okay. So I think, yeah, I would say that, if you compare with Oracle, I wouldn't say that there's an advantage or a disadvantage. It's just that things are done differently. In Postgres, role is the overarching term that is used for users and for groups. So I wouldn't say that there's an advantage over Oracle for using roles for assigning privileges. It's just that things are done differently. And the intent of explaining the roles and privileges was to highlight that there are differences in terminology. And as you move between technologies, you need to be mindful of these differences.
Okay. I think that's probably most of the pertinent questions at this stage. And maybe we'll continue on talking about the database continuity topics. I see there's a couple of questions coming in around that now, and then we'll go back over some of the more questions as they come up at the end. Does that sound good?
Sounds good.
Okay, Alex, I know you've been on mute there for a while, so I will share the presentation.
Listening to Umair do his thing. I like your answers, Umair. I thought that was very concise.
Thank you.
All right, I've got the presentation shared, and over to you, Alex.
I thought you were going to introduce me for a moment there, Tim. Hi, folks. My name is Alex, as Tim mentioned earlier. So I'm the head of product for DBVisit. And being a company that's focused on database disaster recovery, we thought it might be appropriate just towards the end here to cover a few similarities and a few differences between the disaster recovery and high availability options, specifically between Oracle and Postgres, because of course, there's no one better than an Oracle DBA to know and to tell you that disaster recovery is critically important, right? So most of the world's most critical databases run on Oracle. I think is a fair thing to say. Certainly traditionally have done so, and so database continuity is a huge subject for us, and we thought we would cover it off. So Tim, I'll get you to forward us to the next slide, please. Thank you very much. So we're going to try and cover this quite quickly because just like Umair has done throughout this webinar, I just want to give you a general high-level overview of kind of what you're working with between Oracle and Postgres when it comes to DR and HA. So on Oracle, as you can see on the slide there, these are your basic disaster recovery features. So right at the top there is Data Guard, and especially Active Data Guard, a tool that I'm sure most of us are familiar with. This is sort of the default option on Enterprise Edition. You don't get Data Guard, active or otherwise, on Standard Edition. And indeed, that's where one of our key products from DBVisit software comes in. We kind of provide a Data Guard-like tool for Standard Edition on Oracle. The main feature of Active Data Guard is that it offers essentially real-time replication. You can have your primary and standby synchronized almost in real time. That's kind of the main advantage and the reason why they only offer it in Enterprise Edition, of course. Other than that, kind of going down from there is rack and SE2HA. So these are multiple processing nodes with shared storage. It's worth mentioning here that the words high availability have very different meanings between Oracle and Postgres. So in the Oracle world, whenever you talk about any high availability option, really, there's always a shared storage element. High availability in Oracle kind of means you have shared storage. Whereas in the Postgres world, you typically do not. In the Postgres world, we'll get onto it in a moment, but high availability actually generally assumes distinct storage. So this is just important to be aware of that difference, just like the differences with select queries that Umair was going through earlier. And then finally, RMAN, backups are, to this day, arguably the most flexible disaster recovery tool. The backups typically have the worst RTO and RPO of the other options, but they can be used in a huge multitude of ways. You can replicate them to the standby server straight away and apply them, restore them onto your standby. You can catalog them for later use. You can use them for point-in-time recovery, all kinds of things. At a fundamental kind of level, the way to group these into two categories, if you like, is that there are synchronous real-time DR options and asynchronous, which is sort of log file based options. And if we look at what's available for Postgres, and by the way, everything that we're looking at here is available in Postgres open source community edition that Umair was showing earlier. There are really pretty clear parallels between the two. So a rough parallel to Active Data Guard on Postgres is something called streaming replication. So it works a little bit differently to the way that it does on Oracle, but at a high level, it also allows you to have essentially a real-time synchronized standby. So the way it works is the standby cluster actually connects into the primary. So it's not, the primary doesn't push content down to the standby as much as standby draws it out of the primary, if you like. It establishes and maintains a single TCP/IP connection, and then all transactional data basically goes down a pipe. So every time that there's a transactional that's committed on primary, you don't have to create a new TCP/IP connection. All that data is shipped using a single maintained connection. You can run it in synchronous mode and asynchronous mode. Synchronous mode means that it works as essentially as a pessimistic commit for those of you who are familiar with the term. So that basically means that the primary will actually wait to receive confirmation that standby has confirmed a transaction before applying it onto itself. The default is, of course, running it in asynchronous mode. A rough equivalent to the Oracle file shipping methods, the log file shipping methods in Postgres, is something called archive mode replication. And the parallel is really very, very strong. So basically, archive mode replication creates what are called WAL files, which are write-ahead log files, either based on a certain preset interval or based on how busy the primary cluster is, and just dumps them into a directory and calls a callback function. And you can kind of script your own solution there and use it in a multitude of ways, just like you would Oracle log files. You can just generate them on primary and keep them there, use them for point-in-time recovery. You can script them to be sent over to a standby and dump them into a special directory from which Postgres will immediately restore those files onto the standby cluster. Whole bunch of things you can do, but basically archive mode replication is based on file exchange. Just like log files in Oracle, we have write-ahead log files in Postgres. Where we start to get into some differences is with high availability. So Postgres has a number of options for kind of advanced options for high availability. These are not part of the community edition, but they themselves are also open source projects that are freely available, have very permissive licensing, and you can use on the community edition. The most prominent one of these is called Patroni. So this is really an orchestration template and toolset for high availability. It basically, it is based on a distributed messaging architecture where usually etcd or Kubernetes, something like that, where it creates a number of different nodes that all follow a leader. These are completely separate and distinct nodes, right? So they don't share storage, they don't share processing, they don't share anything. And then Patroni is this sort of tool that keeps track of the status of all these nodes. They're all being synchronized to using streaming replication, real-time streaming replication. And then whenever anything happens, Patroni knows which node is the most up to date, and it promotes that node to be what's called a leader. So in the Oracle world, we talk about activating the standby, right? We talk about activating a standby node. In the Postgres world, we talk about promoting a standby node. Patroni is a very powerful tool. It's got a lot of really cool features. It allows you to do load balancing to a degree. It allows you to have a very resilient architecture, but it's really complicated. It really, really is, even by Postgres standards, which of course, Postgres is kind of being an open source project is the land of somewhat distinct utilities that all kind of work together. So Patroni is the next level from that. It's very much a tool for an expert user. Another option is something called pgpool. So unlike Patroni, pgpool is a part of the core Postgres standard community edition, if you like. It's a very similar kind of tool. It has even more advanced load balancing options, but it's also even more complex. Unlike Patroni, pgpool requires its own balancing nodes to be run. So you have to stand up even more nodes to make sure that everything is kept in balance. And again, the setup is kind of a challenge. So there's one other option which I might let Tim talk about this one, since dbvisit is a disaster recovery database continuity company. We thought we'd throw our hat into the ring here as well, and we've developed a little solution for Postgres continuity that Tim will tell you about in a moment.
All right, thank you, Alex. Thanks for the technical depth there. Yeah, so with dbvisit standby, we kind of come from things from a bit of a different idea, right? So in Oracle, our whole goal is to make disaster recovery 100% sure. So we take the guesswork out of it, we take the art form out of it, essentially making it a business decision that you can be guaranteed, because this is your kind of last line of defense. So we came at it from this kind of direction, not from as many features as we could. So that is an enterprise grade DR and backed by 24/7 support by our team. So it focuses on 100% reliability, and to do that we use standardized workflows. Hopefully some of you would have experienced our GUI, where you can basically do any action, and those actions are confirmed as they're being done in around 3 clicks. It's built on top of native Postgres replication methods, so the archive mode that Alex was talking about, and also streaming replication. So you're still getting that really high performance replication that Postgres is built into Postgres. And it's really targeted at newcomers to Postgres and organizations where perhaps you don't have all of that Postgres experience within it, or maybe you don't have a whole lot of workloads within it. So if we kind of put this onto a table to what it looks like, okay, I've taken a lot of liberties here, complexity and things like this probably have a lot of different values in them, but let's just group, complexity implementing a solution, complexity administering that after it's implemented, against performance on the y-axis here, which is, RPO and RTO, but also the automation and being able to fail over the application without the DBA having to reroute that. So in the middle, we have streaming and archive replication. Obviously, streaming is going to have a better RPO and RTO. And then kind of from that, we can either go with more features and capability, load balancing with HA proxy, automated failover with Patroni, but growing that complexity. And then with dbvisit, we're talking about really reducing that complexity, making workflows, very simple, adding in monitoring capabilities to the software, providing information in a very clear view and backing it by 24/7 support. So you can get a kind of feel for the disaster recovery landscape in Postgres with this view here. But really, there's no kind of one best answer here. I think if you go back to it and look at, well, what are my performance needs rather than wants? What are my performance needs for disaster recovery in HA? How many clusters and databases am I going to be deploying on Postgres? Am I just managing one database because this application's got it and I need to manage Postgres now? Or am I investing in the Postgres ecosystem, and am I going to commit to using someone like Stormatics to help us get started and building my skills around Postgres so that I can manage a more technical environment? And this will kind of point you in the right direction. But so you've stuck around to now and got a pretty exciting slide to go to next, which is not the question slide. Where is the slide gone? This is very embarrassing. Okay, so
keeping everybody in suspense.
Well, I'm keeping everyone in suspense because the slide has somehow disappeared. So I will verbally say it. And Erin, could you run the poll?
Definitely. Just 1 second. Let me launch it now.
So basically, we're really excited today to offer, for the first time basically in dbvisit history, a free license for Postgres disaster recovery. So that's dbvisit standby. So this is a 1-year term license for both the primary cluster and the standby cluster, including full 24/7 support. This will be treated as a normal purchase, and so all you have to do is basically say here, yes, I'd like to take this offer up in the poll, and we'll be in contact with you and get you on as a customer and provide you a full 1-year term license for our disaster recovery software. There's a second question here, which is, would you like a technical demo? You could take up offer 1 and say, yeah, I'd love to take up this offer worth $4,500 for this license, and also get a demo of how to use it. So feel free to take us up on both of those offers there. Or maybe you just want to learn a little bit more and try out a demo and see what it's like before you pull the plug. But yeah, this is open to only attendees today. So it's $4,500 of value. It is a full license with no restrictions. And I'm really excited that I got the CEO to sign off on this one. So, I hope you take us up on the offer. So please, if you're interested in that, click yes in the poll, and we'll be in contact with you shortly. And we'll go on to questions. But before that, Alex, have I missed anything, Erin?
No, I don't think so.
Okay, I know we're probably going to run overtime, but I think there's if you want to hop off now, that's also fine. But if you want to ask some questions to either Umair, Alex, or myself, please put them in the chat, and we'll answer those now for the next 10 minutes. Otherwise, really appreciate you attending. Okay, so one question here is, in Oracle, we use RMAN to back up database and export for backup schema. What is the equivalent in Postgres?
So the most popular tools that are used in the Postgres ecosystem are well, very similar to RMAN. It's barman. Right? So that's BARMAN, stands for Backup and Recovery Manager. And the other is PG Backrest, which is an acronym for Postgres Backup and Restore. So Barman and PG Backrest are the tools that are used to achieve equivalent functionality of RMAN.
Thank you very much. Okay. Jason Hill asks, isn't a database in Postgres like a PDB, a pluggable database in Oracle?
So forgive my lack of deep understanding of Oracle. My understanding is that PDBs are used for multi-tenancy in Oracle.
That's right. Alex, do you have any further questions on this? I know we've talked about this with SQL Server a lot, but haven't.
Yeah. Look, it's actually a complex subject. The short answer is it isn't like a PDB in Oracle, and the main reason I say that is because one of the core features, or whatever you want to call it, of a PDB is that it can be plugged in and plugged out. So in Postgres, you cannot plug a database in and out of a cluster. And so, if for that reason, if nothing else, it's not like a PDB. Now, I understand that you might be asking that in terms of like schema arrangement. That does have some merit, but for all intents and purposes, let me put it this way. As a company with 15 years Oracle experience, for what it's worth, we internally do not talk about databases in a cluster like we would PDBs in an Oracle container database.
I think it's a good answer. Thank you.
There's another question here from an anonymous attendee about a trip to the gorgeous place. I take it it's talking about this one. Listen, if if we end up doing enough business together, I'm sure we can arrange something.
That's the best question of the day.
We don't like saying no.
This one's probably quite a good question. Any websites and blogs that give quick references for difference in terminology and concepts between Postgres and Oracle? It's probably something we could send out to attendees afterwards, but are there any resources and websites that you'd recommend, Umair, for people to get connected with?
So I have written a little bit about that. Not nearly enough, not nearly as much as I would like to, but I think that I will increasingly focus on it. So my own blog on Stromatics has some content related to these differences. And there's also some content available on EDB's website. EDB's claim to fame is Oracle to Postgres migration. So they do have some additional content there. So content is available, but I don't think that there's nearly enough of it out there.
Okay, just typing that in there. All right. Okay, so this is around recovery from backups. Is there a way or a tool to find out if I place my database full backup, PG-based backup, and all available WALs to a temporary directory and validate them to see if they will be sufficient for a complete recovery, I guess successful complete recovery, prior to actually initiating the recovery?
Yeah, I was thinking about this one. Umair, what do you reckon? There's nothing I'm immediately aware of.
Yeah, I think that the tooling will help reading and determining what points are covered, but the determination of whether this is enough is probably, you do need some expertise. You do need somebody who has an understanding of what to expect in order to determine. I don't think that if there's a way to automate it, I'm not aware of it.
Also, yeah, I mean, just to add to that, ultimately, look, ultimately, the only way you're going to know, and this is the same on Oracle, okay, is you kind of need to try it, because otherwise you're always risking the possibility of failure here. If I had to tell you with 100% certainty whether you're going to be able to achieve successful recovery or not based on a handful of data points, I would be very hesitant to do so without just trying it. So in a scenario that you're proposing, sir, If you've got the full backup, you got all the files available, what I would do is I would just copy them to another location, stand up a new cluster based on that full backup, and try it. Unless your full backup is truly an enormous size, it shouldn't take all that long, and you'd know for sure.
And also, I don't think that it is said enough. It's extremely, extremely important to periodically verify your backups.
Absolutely.
Because you don't want to find out that your backups are not working when you really need them.
And you would be very surprised how often that happens with very good companies.
Yes.
Yep.
Yeah.
There's a question about just getting your head around the concept of vacuuming is a big change in thinking in Postgres. Umair, do you want to speak to that a little bit?
It is indeed. I think that the way concurrency is implemented is quite different. The good news is that you don't really need to think about it a whole lot. A lot of this is just it just works, and it's behind the scenes. It just works.
Yeah.
Right.
Yep. In the infamous words of Todd Howard, it just works. The good thing about Postgres concurrency is that if you do kind of get very deep down into it, indeed, it's what in part allows for very advanced solutions like active-active Patroni setups and all kinds of things like that really wouldn't be possible in any other database.
Yeah, I mean, we've had lots of debates on that implementation, and there are schools of thought that vigorously disagree with each other. But I do think that the way MDCC has been implemented in Postgres, while it does require that vacuuming process, the implementation is very solid, very reliable, and there's a lot that you can achieve.
All right. Well, we have exhausted the questions.
I'll just say one more thing, just with regards to that question about verifying full backup with while backups present and is it going to work or not. So, shameless plug, if you were using dbvisit's standby MP for Postgres tool, we do have functionality in the tool that will give you warning ahead of time if you are missing a while backup in the chain. Right. So if you're using archive mode and you're continually shipping while backups to a standby, and something happens to happen to one of them, disk corruption, or you delete it by accident, or whatever else happens, our tool would give you a warning straight away.
Oh,
shameless plug over.
Sorry, one more question, and we'll stop here. Any BSFI, e.g. core banking, using Postgres?
So one of the core banking implementers that we are working with is Temenos, they support different databases, including Postgres as well as Oracle. So Temenos, I know, implements it, and they're one of the logos that I showed in my slide of global brands that use Postgres is STC, and their payment platform uses Temenos, and they're a customer. So yeah, that's one example of somebody that I'm working with directly. There are other payment providers and fintech organizations, many of them that use Postgres, but that is one example that comes to mind about core banking.
Excellent. Well, I really appreciate your time today, Umair. It's been a really great session. It's been great having you as our keynote speaker today and speaking to the Oracle community. Alex, yourself also, thank you so much for providing the information on disaster recovery. And yeah, let's sign out here. Thank you everyone for attending today.
Yeah, always a pleasure to speak with you, gentlemen. Thank you everyone for attending. We'll see you next time.